Good evening. First, congratulations to all of this year's inductees. And I want to say that it is a pleasure and an honor for me to be here tonight to talk about Julia Morgan, a person I spent quite a bit of time studying. It's fair to say, well, Julia Morgan first, she was, in 1894, she became the fourth woman to earn a degree in civil engineering from the University of California, and the only woman to do so that year. And it's fair to say that her education in civil engineering was foundational to her unlikely and pretty phenomenally successful career in architecture during the first half of the 20th century in both obvious and subtle ways. She learned the basics of the math and science behind making a building and a structure stand. She also was exposed to the highly masculine culture of architecture and engineering as she sat the only woman in the classroom surrounded by a sea of men. But of course, that was nothing compared to the culture of masculinity that she encountered when she got to Paris, where she went to study at the Ecole des BeauxArts, which was then the most prestigious architectural school in the world. The ateliers closed their doors to her. They said, "You have fantastic talent, but really you're not going to fit in with our culture of drinking and smoking and pranks and mentoring. So thank you, but no thank you." So thanks to the grace of two men, Marcel Pérouse de Monclos and Benjamin François Chosmich, she did find the mentorship she needed to get into the Ecole. You had to have an affiliation with an atelier. It was quite a saga getting into the Ecole, but eventually she did, becoming the first woman to be admitted to the architecture program at the Ecole des BeauxArts in 1898. And while she was there, she earned an education. She had an education in neoclassicism and Gothic architecture, the very artistic side of architecture. But the Ecole was really going through a crisis when Julia Morgan started in 1898. Not only were women knocking at their doors, which was challenging, but foreigners were knocking at their doors. Since the mid-19th century, the École des Beaux-Arts became the most prestigious school, and Americans, more than any other group, were flocking to Paris to get the best education in architecture at the time, which ironically, the Ecole saw as sort of undermining its authority and undermining access for French people to gain the best education in architecture. So they limited the number of foreign applicants who could gain acceptance in any examination period. So that upped the ante, the competition for Morgan. But another thing was happening too, also kind of related to Americans. There was that thing, steel, skyscrapers, those ugly, sinful skyscrapers in America. And the impact of engineering to architecture in the late 19th century completely threw the Ecole off in terms of understanding what is architecture. Is it art? Is it engineering? And in 1889, this structure that you might recognize, the Eiffel Tower, was constructed, and it proved that steel construction could be beautiful. It was the response to those monstrous American skyscrapers that were being constructed in Chicago and New York and other cities. But nobody from the Ecole designed this. Gustave Eiffel, he was an engineer. So now, an engineer was creating the most famous structure in the world. Well, the Ecole couldn't have that. So when Julia Morgan arrived, the Ecole was increasing the entrance requirements in math and physics, and it instituted a very, very challenging curriculum in construction. It was the one course that was mandatory for all students, And when students were taking the construction course, it was the only course that they were taking at that time. It took the whole year. Ironically, American students like Julia Morgan, who often came with degrees in civil engineering, they had an advantage over the French or any other people getting into the Ecole because they had the math and science to pass that part of the examination. And so Julia Morgan came in from Cal with this knowledge of math and engineering. And so she was able to pass that part of the entrance examination once she remembered to use the metric system with flying colors. And she loved the construction course. And when she came out of the Ecole des BeauxArts, she had the cutting edge, even more so the cutting edge training in the science behind buildings. And so that kind of education made her appealing to John Galen Howard, who was then the head architect at UC, implementing the new BeauxArts campus, the grand campus that Phoebe Hearst had underwritten recently while Julia Morgan was in Paris. And so John Galen Howard kind of did the basic design of the Greek theater, but Julia Morgan was, I think you'd kind of say, the architect of record at the time. She's the one who had the science, the engineering, that education behind her to actually execute this concrete building. It's inconclusive to me, and maybe somebody here knows if this is actually reinforced concrete. The structural, it's not, right? It's not, yeah. It's concrete, okay? But it is, what's that? Now it's reinforced, that's right, yeah. Julia Morgan wasn't the architect, John Galen Howard was. He didn't have the education. But she did help to create a beautiful concrete building at a time when concrete was really used for bridges, for viaducts, for infrastructure, civil engineering stuff. She then moved on to Mills College, where she designed the Campanile. It's the first freestanding campanile in west of the Mississippi in the United States, I believe. And this is a reinforced concrete building. And she worked along with Bernard Ransom to create this building, and he tried to take all the credit. But when the earthquake of 1906 hit, and the newly finished reinforced concrete campanile in the Mission style, kind of pretty, survived without a crack, it catapulted Julia Morgan's career to new heights. She not only designed buildings with the latest technology, but also, again, beautiful. And she also was just working on the finishing touches to the Margaret Carnegie Library at Mills College, also a reinforced concrete building, and only some ceramic tiles cracked. So that reputation, again, really a combination now of style with technology and engineering, helped Julia Morgan land the career that really set off her future. The Fairmont Hotel had been completed just before the earthquake hit in 1906, and the exterior survived pretty much just fine, but not the interior. The columns had been inadequately cased, and so the heat of the fires that surged up from the ports penetrated the columns, and the steel began to melt. As the steel melted, I'm talking to a bunch of engineers, but as the steel melted, the columns began to bend, the ceilings began to sag, the floors buckled, the walls fell in. And somebody needed to fix this building. No architect wanted it. No engineer wanted it. But Julia Morgan, who now had this reputation for building solid structures in the most modern technologies, was offered the job and had the audacity to take it. And a year to the day after the earthquake of 1906, the Fairmont Hotel reopened. So Julia Morgan, over that year, all of her work was structural. She had nothing to do with design, nothing to do with decoration. That art, that Rococo thing that's going on inside, that's not her. She made the dome work, gigantic dome work. She made the columns stand. She made the ceilings stay put. And her ability to manage such a complex engineering project within a year, managing a bunch of men, no offense, in construction, electrical guys, plumbing, this incredible world of men in a year, prompted a man to say, just as the building was about to open, that, her name is Julia Morgan, but it might as well have been John Morgan. So she had been able to talk to all these men in the different building trades on their level. She understood how the building worked. And that is vital for her to be able to have that authority in this profession that was dominated so dramatically by men. If she had been the designer, that probably wouldn't have been quite the same story. Over the next couple of years, she just reinforced her reputation as a practitioner of the latest technology in reinforced concrete. Here's the Viavi building. It's one of the first mission-style buildings. Again, reinforced concrete had been functional, and here she made reinforced concrete decorative and functional. And fireproof. She built a fireproof building. That was important too after the earthquake and fires. She also experimented in reinforced concrete housing. So this building is still on Piedmont Avenue in Berkeley. This is the Green and Green building, right, at Bancroft and Piedmont. So this is next door, and a fraternity covered up the front, and it has a volleyball court in front and a parking garage. But the interior is still there, and it's still a reinforced concrete house, and one of the earliest ones ever. So she, again, built this reputation as very experimental in structural design. The other style that Julia Morgan's renowned for is the First Bay tradition. This building exemplifies it, right? And characteristic to Julia Morgan's First Bay tradition buildings are the exposed trusses, right? Roof beams and trusses. And this is St. John's Presbyterian Church, which is now the Julia Morgan Theater on College Avenue. And so this you'll find in loads of Julia Morgan buildings at Asilomar. In some houses, you'll find the exposed trusses. But then you also have here, all of this work is the framing, which is to say to me that Julia Morgan, she had a very small budget for the building, but her love for engineering, her interest in engineering guided her designs. She saw the beauty in it. And so those, that's just framing, is really quite beautiful because Julia Morgan understood and loved the engineering behind buildings. She always stayed on top of the latest technologies. This is the chapel at Asilomar in Pacific Grove. And in 1914, the technology was made available for large sheets of rolled glass, of plate glass. So in 1916, she made sure that she used that technology. So it's a very simple building, right? It's a wood frame building with apparently very simple engineering with the most modern glass window technology of the day. But soon, really, pretty soon, Julia Morgan's knowledge, or the technology moved well beyond Julia Morgan's knowledge, and she relied upon other people to figure out how to solve the structural problems, the engineering problems to her buildings. Walter Steilberg is an engineer, a structural engineer, who worked with her for decades and decades. And In his career, he did the first retrofit of the Memorial Stadium around World War II. He was into research. He patented a lot of fireproof technology. He was always on top of the latest technology in structural engineering. When he was 85 years old, he said that the Berkeley Women's City Club, now the Berkeley City Club, was the most complex structural engineering problem he ever had to face. So it's a reinforced concrete building, six stories high at the highest point. And you can see everything, almost everything in that building is reinforced concrete and plaster. So it's very complex and it's designed just in decorative terms. It's neo-Gothic in places, right? It's got the rosettes, right? The florets, the columns. It's complex in that sense. But the elevation perhaps tells us a little bit more. And I would love for any structural engineer to talk to me about this. And I see a fellow board member from LHF over there. The building's about to undergo an examination of its structural integrity. So we're going to have a structural engineer look at it. But from what I can tell, what you have is you have a massive reinforced concrete building in a complex decorative style that has intersecting planes and multiple stories, intersecting planes that apparently, I guess, is going to have different shear factors or something. I don't know. Right? Like, I don't know. It's like an earthquake's going to come and it's going to be going like this, But it's also one cavernous space after another. And at the base of these cavernous spaces is this pool, which is a very humid environment. And we know that, the humidity and aeration is affecting the windows. And once your windows are affected, then it's going to penetrate the walls and the moisture is going to get in and compromise the structure and all of that. So it's one cavernous space on top of another in these intersecting planes. And then on top of that, the building is designed actually to hold. So here we have the pool, and on top of the pool is a library. That's a cavernous space. And then you have this terrace where people are going to dance and bounce around. And then behind there you have an auditorium, which runs all the length of the two planes here. And then it's designed to hold 2 more stories of residential area above the auditorium. So these 2 stories don't actually exist. The Great Depression hit and the finances ran dry. But nonetheless, this building is designed to hold even more weight capacity on top of it. So all of those things tell me it's a pretty complex building. Anyway, so my point actually is that, okay, so Walter Stylberg, he had to figure out the engineering for this building. This is 1929. Julia Morgan understood she didn't have the math anymore. She didn't have the science and technology at her hands to be able to do those calculations. She was very, very busy too. She didn't do that. She delegated that. But what Walter Stylberg noted was that she still had the imagination, the understanding of how buildings worked, to be able to imagine that this building could stand. And then, I'm a historian, we're going to get into metaphor. And then when I think of Julia Morgan's career in engineering and legacy in legacy, I can't help but think about her relationship to women. And this diagram here, it's my great procrastination exercise in graduate school. I just started with one client. This client connects to 80 other clients for whom Julia Morgan designed houses, and they're connected through a network of women's institutions, or largely women's institutions, that ranged in function from the Red Cross, from medicine to education to juvenile justice and juvenile delinquency, to social events, to the environment, and capture the vast range of causes that women were invested in a century ago, more and less. And so I often think of Julia Morgan as the architect or engineer of the California women's movement of the progressive era. And really, it's the small department of civil engineering at the University of California in 1890 to 1894 that opened its doors to this young Victorian woman and said, pursue your dream.